Hi, and welcome to this very special edition of Coffee with Developers. It's very special because this time we don't have a coffee, but we have a very nice car. And together with me today is David Romić, who is the product strategy manager of Rimac. So very much looking forward to having an insightful conversation in a very nice car with him. So, David, welcome to this show.
Thank you for having me.
So you have a nice seat?
Yes, the driver's seat of one of the most interesting and most powerful cars in the world.
Yeah. So we are here in the Rimac Nevera, and we can't drink coffee because if we spill something, then probably that's not so good.
Yeah.
It is the fastest hypercar in the world, right?
Correct, yeah.
So 1.8 seconds from 0 to 100.
Yes, 1.81 if I'm not mistaken, 0 to 100 and 0 to 60 in under 174.
Wow, that's super impressive. And we are gonna spend the next, let's say, 20 to 30 minutes talking about what are the challenges of software development for a hypercar, how does that work at Rimac, what is your role in these kind of things. So it's going to be an interesting discussion, I think, with a few insights. But first of all, let's talk a bit about the car. So what can you tell us about it? Like what are some specialties? What differentiates it from other automotives? And also I heard it broke like 23 records
yes, it did.
In one day.
Yeah, in one day, and then we added the 24th just a couple of weeks back as well. So,
oh, really?
Yeah.
So what are these kind of records?
So most of them are actually acceleration records. Different times from 0 to 60, 0 to 200, 200 to 300, 0 to 300, then back to 0, stuff like this.
Yeah.
So essentially every possible metric that you can think of in terms of high performance cars, this car managed to break it.
Yeah,
in just a single day during a single event.
Wow. That was in Germany?
Yes, on the test track.
Yeah. Okay, Nürburgring.
I'm not sure if it was on the ring. Yeah, but it was on a test track. But we went on the ring with the car as well, and it set the record for the fastest EV car fastest EV production car.
Yeah. Wow, that is amazing. And I mean, this is the Nevera. Before the Nevera, you had the Concept 2, right?
Concept
C2?
1. No,
Concept 1?
So C2 was the code name, the development
Nevera,
code. Development code name, because we had the Concept 1, then C2 back when we were developing it before we named the car Nevera. Concept 1 was the first car the company did.
Yeah.
That was way back when, I believe in 2013, we unveiled it at Frankfurt Auto Show. That's a very interesting and famous car as well.
Yeah.
It had a lot of its own history. It was the first electric hypercar.
Yeah.
First one to put four motors, one motor at each wheel. The same topology, the same architecture that we have in this car as well. But what probably made it even more famous was the crash that happened during the premiere of the season 2 of Grand Tour with Richard Hammond. Yeah.
Google Richard Hammond.
Yeah.
If you don't know it yet. Yeah. But I would say it was popular before that as well. So that's interesting. I have to say it's very comfortable actually.
Yes.
Sitting here, like for such a hypercar, it's like for the audience, like we have radio, we have very nice seats, sport seats, obviously. You even as a passenger, you have a kind of a second screen where you can see the speed and some settings and so on.
Yeah. One of the designing principle of this car, it was not just to make it a cramped sports car that is comfortable only on track, uncomfortable even on the track, but to make a Grand Tour essentially. So things like the leg position, the leg angle, knee angles, the headroom inside the car. If you take a look, you can see that there's like a little
plenty of space.
Plenty of space. So that was one of the, as I said, designing principles. And we're not just talking about the interior. This same designing principle that we need to make room for the car, for the driver and the passenger, went into designing the components. So the battery layout had to adapt to the ride and comfort, not just the performance.
So it's all about the user experience.
Yes. It's very much UX-driven car. If you like. Yeah.
That's great. How many people work at Rimac actually?
So currently, Rimac Group is what we are now, what we became in these past 10 years. Rimac Group consists of Bugatti Rimac and Rimac Technology. Rimac Technology is the tier one supplier, as the standard name in the industry, meaning that we are focused on producing the individual components for other car manufacturers, not only our internal development. And Bugatti Rimac is a joint venture between Bugatti essentially and Rimac Automotive.
Yeah, I mean, so that was a big news. Like, I mean, Rimac taking over kind of Bugatti. Wow.
I mean, it's a testament to what we did essentially in the past. So we were a small startup. The same Cinderella story, right? You start in the garage, you start building a project, etc., etc.
In a garage in Croatia on the Balkans. So it's not like Silicon Valley or something. It's like
and
that is
in
impressive.
a country where you don't have automotive industry in the traditional sense. I mean, there are of course companies here and there producing various things, but there is no car brand, there is no big tier one supplier in Croatia. So to build both at the same time and to get a recognition from Volkswagen and Porsche through investments, not only capital investments in terms of cash, but also to say, okay, guys, you're doing a very good job. We want you also to usher Bugatti into 21st century, into the new era essentially of electrification. So. Going back to the question. So now we are with all these expansions, mergers, and all of this. The whole group is around 2,000 people.
2,000 people.
Yeah, 2,000 people. Back when I joined 6 years ago, it was less than 300.
I remember that. I visited once a year. I have one meeting here or a visit or so on. And I remember a couple of years ago, I think it was 400 people back then.
Yeah.
And actually, I mean, we are now also in the Rimac factory in Zagreb, and it was I think there wasn't even enough space for the parking of 300,000 employees and these kind of things. So that grew massive.
That's for a car company. That's one of the biggest complaints: the parking space. So 600 people in Bugatti Rimac, 1,400 people in Rimac Technology. We are spread out all over Europe, mostly concentrated in Zagreb in Croatia, but we have offices in Osijek, in Split. We have offices in Warwick in UK. In Berlin. Berlin is mostly Bugatti Rimac's design office, as well with some engineering. France, of course, in Molsheim. And Italy, good.
Don't forget Italy.
A lot of Italian colleagues as well. We have a rapidly expanding office in Italy as well. But that's for the whole group. Now it gets a bit complicated when you try to figure out who works where. But for the sake of argument, let's talk about the group.
Yeah. Okay. And then let's think about traditional car companies, and not so many years ago. It's about bending metal, building chassis, and these kind of things. But I would assume that in your group, most people are actually sitting behind the desk and doing software or embedded programming.
Not most, but I would say a much larger percentage. It's a much larger percentage we have in the company of actual software R&D, not just software, all types of R&D, than traditional OEM. So we are. So it's still about bending metal and shaping carbon, right? So you still need to put something on top of wheels. But what is quite different from very large companies, and especially in new versus old, right? Meaning companies which started recently and especially focusing on EVs, and companies who have existed for 100 years and have been doing this for a very long time, is that let's say the spark to start a company. A lot of companies have been started around this new era of electric vehicles. And electric vehicles, they brought a lot of changes to the industry and a lot of new development. So you didn't have established supply chains when you went out to building a car, and that's the main story of Rimac as well. So I mean, we back in more than 10 years ago.
You had to do everything yourself.
Exactly. I say we. I was working back then. It was only 5 guys, 10 guys, 15 in the early years. But essentially, they wanted to go to the traditional route. They wanted to source the components. Whoops! Activate radio.
Radio.
I pressed the brake pedal and the car woke up. But yeah, essentially they wanted to go with the traditional route, and they wanted to source components from all these companies and essentially just assemble the car, put a badge on it, tweak it, tune it, calibrate it, and sell it. And they found out very early that it's not quite possible without a lot of money, and B, it's not possible at all if you're trying to build an electric car in 2010. Right. So at that point, you just out of sheer desperation, right, you had to build all of these components yourself. So maybe not the motors, but definitely the battery. So there was no one to supply the battery. And when we started building this, when we started assembling Concept 1, we quickly learned out, okay, there's a lot of interest in this business, both for EVs and the components that build EVs. And long story short, throughout 10 years, we split these two businesses, like one supplying the components, another focusing on the final product, right? The more of the integration, calibration, ride and handling, performance and stuff like this. Not worry that much in a sense of the intricacies of building the battery. They have the specification, they want it, they need it, they will package it, and it will be exactly as they said. But the other part of the company is concerned with actually building the battery. That goes for the infotainment system, for all these things. So as I said, like out of sheer desperation, we had to build this business, and it proved to be a very, very successful, very lucrative business, and it showed a lot of interest from the old industry, right?
Yeah, because I mean, essentially, maybe that's an upside because I would say like the old economy, they didn't have this pressure. They want to do the traditional thing as long as it goes. And as you say, like out of desperation, you start innovation. Right?
Yeah, exactly. That's that's very well put.
That's how it often works, right? So, but yeah, coming back, like okay, so Rimac's more than 2,000 employees, many kind of locations, many different brands, many clients. As we said, like many people working on software. How is it different, like to well, let's get back. Let's make first this question. Like, what is your role in all of this?
So that's so I started as an engineer 6 years ago, working on one of these various subsystems that you can see today. Then throughout very quickly due to the rapid growth and all of this, I was actually tasked for the past couple of years mostly running the embedded software department. So all of the components, everything that's pretty much under the hood that makes the car run, going from the battery, from the motors, the inverters, even the pumps and fans, even all these buttons that are moving the windows up and down, all of this is done in-house. You announced me as the product strategy manager. That's a new role for me, but so I won't talk much about it because it's very fresh. But I'll focus on my experience as the software guy here. So what's very much different is that all car companies, they have software engineers. Let's say it's inevitable. It's a necessary evil. I would say you need to make the car run. You need to change things. They are very digital and so on. But going from, if you take a look at the vehicle, any vehicle, if you take it apart, you will see when you open up the hood, when you remove the body panels, you will oftentimes see electric components which have not the, for example, Volkswagen logo on it. They don't have Mercedes-Benz logo on it. They have some tier 1 supplier logo on it. What is different here is when you take everything apart, you essentially see a lot of these components that make the car run, a lot of these ECUs, as electronic control units, and they are all stamped with Rimac's logo. So, and I say that proudly because that means that's a clear signal that we have built this car from scratch. So this is a blank sheet of paper car. And what reminds me is that remembers me like of Apple user experience. You do your own components. You do your everything kind of should work together well, which is obviously kind of an upside when you do things yourself, as much as it makes sense, obviously, and as much as it is feasible, instead of like putting different parts together. So I mean, you have total control of the look and feel of your product, which is essentially the reasons. I mean, in these kind of markets, this is what people want, right? So you can customize everything. So there are no compromises on the look and feel. That goes anywhere from the shape of the steering wheel. So this is a bespoke steering wheel, right?
Yeah.
This is not a carryover component from any other car, and that, just to save us time, that stands for every component in this car, except maybe the belts and the seats. Well, no, not the seats. The seat design is still bespoke for this car, but everything that kind of matters to the owner, to the driver, and the passenger, it's been purpose built for this car, and you cannot find any of these components, right? Even the electronic units that are moving the windows and moving the seats, which are trivial things. We've done them ourselves, again, out of combination of desperation and control, and this obsessiveness over controlling the end product.
Makes sense. I mean, it's a very special product, so it makes sense to kind of look at these details. I mean, there are many engineers, developers, tech people interested in cars, like, who wonder what is behind the curtain, like what does like a software architecture of such a car look like? What are some kind of main components, or like tech stack, or programming languages, or like what are the big bits and pieces that you work around? If you can kind of summarize that in a few sentences.
It's interesting now, in 2023, when you look at the tech stack of the car, when you do like a breakdown of the architecture, going from in-vehicle systems all the way to off-vehicle systems, you have everything. Like you have the let's say the brain of the car, and all of these things, all of these functions, all of these things that are moving, the wheels and the windows. I use always those two things as extremes, right? Because from 2,000 horsepower to just a couple of watts of moving things up and down, it's all pretty much C, and we're using also some other tools like MATLAB and Simulink to model and then transcribe the code, transpile the code back to C again. But as you move, let's say, higher, if you go to the infotainment system, so this infotainment system is mostly C++ and Qt framework, right? And then you go off car into telemetry system, because this is a connected car. Like, we have the 5G antennas and Wi-Fi and all of this. And then you get into the typical, webosphere with, we have the dashboards, we have the mobile app.
So it's basically web development,
exactly. There you have everything, like the latest.
So actually, there is kind of a role or space for every kind of software developer, not depending on the stack. Like, if you're a JavaScript guy, you have kind of can find some jobs to do here.
We even have some JavaScript on the JavaScript elements here running the infotainment. So I mean, if you have any kind of skill set and interest in the automotive industry today, you can work in it, right? Whatever it is that you do. If you like cars, it doesn't matter. Well, you can learn, right? Same way you learn JavaScript, you can learn C. But the point is, whatever your skill set is, you're needed.
How was it for yourself? Like 6 years ago, I mean, you've been an engineer. Why did you join Rimac? So, like, did you always have a passion for cars, or was it just like coincidence, or
a bit of both? So I always wanted to work with like low-level stuff. I wanted to make things move, make things light up,
touch something.
Exactly. I very much like this combination of software and hardware. And I started working in a local company and doing embedded stuff, and I was having a lot of fun. And I knew Rimac was doing all these things, but I felt I had a bit of a imposter syndrome back then. Like, I don't know anything about cars. Why would I have it? But they reached out, and I decided what the hell? I got nothing to lose. The worst they can say is no. Right. So I went to the interview. They liked me. I liked them. I got an offer and I started. And the first couple of months I will admit it, were a bit scary. Going into a rapidly growing company where things are moving very, very quickly, and you're at the very beginning of your career, and you've just moved into completely different area. So, but
it was like that, like probably for most of the people working there already,
here,
right?
So I quickly figured out, like, whoever I talked to, they were having the same kind of anxiety, right? But then you realize, okay, we're all in the same boat. That's it. We just have to make it work. It's do or die, right?
Sounds also like a lot of fun, actually.
Yeah, it is. Yeah, it is.
I mean, like a lot of innovation, fun. also trust, like, hey, just do what you think is right and try to find solutions to
That's
challenges,
exactly
problems, and so on.
Yeah, that's exactly as it was. As I said, at the very beginning of my career, you are entrusted not only with a very important piece of the vehicle, but also with something like running a team eventually. Oops,
the radio.
Radio
pushed some
activated.
buttons.
Yeah, pushed something. We need to keep our hands clean. But yeah, you get entrusted. Not just. It's an opportunity. It's an opportunity to grow. We always joked how this company is a pressure cooker, right?
Yeah.
Where it might take somewhere 5 to 10 years. You need to do it in like 1 or 2.
Yeah.
So I'm not gonna lie. It was stressful at times. It was hard. It was difficult. Whenever you try to achieve something like this, it's never easy. But so far it's been very, very rewarding. And the time of my life.
I mean, it is a big story. It is like. I think you can also like grow with that kind of company, and that's of course it has to work out, but it seems that it rocks. So it's a good story.
It worked out for us and for the company. So look, we have from the people who a lot of people. So when you look at a lot of companies, when you look at the trends of employment nowadays, you see people changing jobs every couple of years. And what we've noticed here, I mean, of course, there's some people coming and going, and we are expanding, but a lot of the, let's say, a large percentage of the initial crowd is still here. There's a lot of people with a long tenure, so we're doing something right. Maybe not everything, but we're doing something right.
Let's come back a bit to the car and the systems. Like, I mean, what would you say like is from an engineering aspect the most maybe challenging part? Is it the torque system, or is it?
That's a tricky question, because whoever you ask, they will say that this thing that I'm working on. That's the more difficult. That's the most difficult part. But let's say I had like an overview. So I'm not gonna go into what is most challenging.
I'll just name a few of them.
But of course, the powertrain system. You need to push this car to achieve these amazing numbers, and it's a heavy car. It's an EV. It weighs over
Let's
2
go
tons.
deeper there. Like what is when you accelerate the car from 0 to 100 in this 1.8 seconds? Like what happens in the background?
What happens in the background?
What happens? What kind of software? What kind of functions get called? Like what happens?
So usually when you want to do like an acceleration run, you will put it in a launch mode. And launching this car is very easy, which we will show on the track when we go there. Launching it's very easy. You essentially put your left foot on the brake pedal, and you put your right foot all the way to the accelerator pedal, and that's it. The car immediately loads. Launch control. Everything loads. Everything is set. The car enters this mode. It says, "Okay, I detected all this." So all this main system, which detects the pedals, informs all the other systems. Okay, we're going for a launch. And from the
all
moment,
the other systems are like
everything from cooling to the inverters which are running the motors, from the battery, from all
battery
of these.
heating up.
Exactly. The cooling systems, everything, the active aerodynamics, everything gets ready to go high performance. So you have this network of devices which communicate to each other, each of these devices are connected to a physical system.
And there is one central computing unit? Or?
Yeah. From that computer you get essentially aggregation. You aggregate all the data. It chews it up, so it decides, okay, this is the user input, and it sends the commands there. So for the acceleration, it's very simple. As I said, from the user perspective, you press the brake, you press the accelerator, and then you move the brake. You move your foot off the brake pedal, and the car will launch. Where it gets a bit more fun and a bit more interesting is when you start doing a lot of dynamic stuff. When you start cornering, when you start, if you want to enter the drift,
or let's say it rains and you want to drive fast, it's aquaplaning, then you have to.
Then you have a bunch of sensors feeding into data. So again, it's all about data. It's all about the user input and the capability and the environment of the car. So things like the angle of the steering wheel, the forces that you can even see here, the lateral and
on the second screen.
So all of this information is taken into account into this central computer, which can then individually control all 4 wheels. So when you're entering a corner, depending on the grip, depending on the speed, on the force, on the user input, on the position of the pedals, whether you're braking or accelerating, the car will send an individualized command to each wheel.
Yeah.
So the outer wheels, for example, will help you exit the left turning corner, if the right wheels, etc. So essentially, it's a very complex network of computers that are all connected to the car. Yeah, it's a cyborg.
So latency is quite a thing.
Yes. So this is what we call the hard real-time system.
Yeah.
Right. So hard real-time system, you need to have a very predictive input to output time definition. So you cannot, when you open your computer, your phone, sometimes it lags a bit, right?
Yeah, right.
And you don't want lag on your brake pedal. Not at all, right?
No.
So these are all things that go into consideration when designing these systems, not only designing but validating and at one point you need to be very confident when you give your customers who paid a lot of money for a car such as this, and they will ride it hard, most likely, that they can do it safely. So a lot of time is spent writing software, testing software, etc., etc. But so I mean, I am a software engineer, but I want to emphasize, like, writing software here and in an automotive business and different from that is that you need to take into account everything, right?
Yeah.
So you need to go from software to hardware. You need to understand what it is that you're controlling. Fine, at a certain point you cut off, right?
Yeah.
You don't need to understand the very fine details, but you cannot really put yourself into a silo and say, okay, I wrote this according to spec. I don't care what it is, right?
Yeah.
So you need to have a bit of a higher ownership of what it is that you do.
Yeah.
You need to support your colleagues, especially during the development phase, especially during the final phases, right, when we are racing to send the car to production and off to the customers. And this same goes for over-the-air updates and stuff like this. So we can change the car drastically, right, just writing software. So that's why, it's very different mindset and a very different kind of weight.
You have to understand the whole thing. So what are the implications?
Yeah,
and so
because
on.
essentially someone will sit behind this wheel, and you told them that you can do like a very fast run safely, and you need to be confident.
Yeah,
and you need to be not just confident. Confidence
it's
is
not a toy.
It's not a toy.
It's very it's a serious thing.
Yeah.
You mentioned one thing, testing.
Yeah.
How do you test that?
Yeah. So going back a bit to the traditional OEM and stuff that we do here. So traditional OEMs, they have a network of suppliers, right?
Yeah.
And there's like oftentimes a cutoff between
specification requirements. You get it.
We need this box, and we will connect it to this, and that, and it needs to run. That is fine. That is a great approach if you can make it work. As I said, we couldn't make it work when we started, so we had to do everything on our own, and that had a very serious consequence. That we are essentially, as a software engineer, you design a component, but you design the car, right? And you have this communication with the whole chain of people who are building this car. You don't have a customer-client relationship in a traditional sense, and that means working as a software engineer in Rimac has been exciting. You get to see a lot of these scenarios in your life, right? You get to test things on the living car, and you get to go through various stages of testing. Yeah. Now, for stages of testing, right, it's very much traditional. Yeah. In a sense that you do various software in the loop kind of testing. You do unit testing. You do some kind of dynamic behaviors. You essentially bombard the software unit you designed with various inputs and expected outputs, right? From that point, you integrate it into what we call a system, and then you do a system validation, system verification, qualification, all these fancy words, which essentially means you connect your little box to some kind of physical inputs that you expect to control. Once you pass this stage and several other stages, you get to the vehicle. Right? Yeah. So the final environment, the final testing environment is actually, you take a passenger seat with the laptop on, you take a test engineer here who knows the car, who knows, let's say, more about the performance, and then they will start driving the car heavy, and you need to look at your screen, you need to look at the logs to see, and the telemetry system, which we use quite a lot for testing and development. But essentially, you cannot cut any corners, right?
You need to do it, like for the security reasons.
Exactly, for security and safety. So regardless of the fact that we are this conjoined unit, that we are under a single roof, you still need to do all these steps, and that's the, I would call, beauty of it, that you get to do not just these first steps that you would do in any other company, but you get to do all the other steps, right? This.
So it's just like taking it even more serious.
Yeah.
Hey, that's cool. I'm slowly coming to an end. Like maybe just a few sentences about the car. Like just watching these buttons. So it's interesting. It has it has 4 modes, like range, cruise, sport, and track. Right?
Yeah, let's see. Range, cruise, sport, track, and then you forgot one. Drift.
Oh yeah, drift.
Actually,
And essentially, what you have is like, maybe we'll have some pictures later. Like you have these kind of 2 knobs. Like one is for changing the modes. You can also have custom modes actually.
Yeah, you can.
And then depending on that mode, you have a second knob where you kind of also transfer the torque from front to back and so on. So in drift you have basically 100% in the back.
Yeah.
And cruise it's more on the front bias. What I find interesting is like actually it's you could use it as an everyday car because it has 500 kilometers WLTP.
550, like I believe. Yeah.
So actually, you can drive it around in cruise mode.
You can daily
or range mode.
Yeah, I know one guy who will daily it very soon when he receives his RCO.
And he's also like he has this Bugatti, right? This Bugatti,
this right behind us.
And I learned that usually like these kind of Bugattis, although they are very, very, very expensive, obviously, most of them have a kind of lifetime mileage of I don't know, like 30 or 40 or 20 or something, like yearly kind of actually.
Yeah, a lot of hypercars, a lot of these expensive cars, they are oftentimes like not only a second or third car, they're the 50th car, right?
Yeah.
So they spend a lot of their time in garages and for fancy events, maybe track stuff like this, which as if you're working on it, you expect it. That people will buy this because it's not just a car, a powerful car. It's oftentimes a beautiful piece of art. Sometimes it's an investment. It appreciates and stuff like this.
Sometimes it's just fun because they can do it.
But as an engineer, you're most happy when you hear about one car being driven hard. So I mean, this is one of the I don't know how many test
more
vehicles.
More than 30k kilometers.
Exactly. So this is beautiful to see on this car. It's a test car. Obviously, it spent a lot of its time in various tracks and various conditions. But we hope actually that we will see a lot of our customers actually use the car. As I said, I know at least one.
I hope we see them on the roads because you can drive them on the roads.
It's a very comfortable GT. With a lot of Grand Tour, with a lot of space, a lot of
It's very comfortable, as I said. It's really you have really a lot of space.
Yeah, you can imagine yourself driving this daily.
It would be good to to be able to drink a coffee in that barn. But I mean, probably if I would buy one at some point,
I think you can customize it maybe.
Then I can maybe get a
coffee.
Get a coffee and maybe an ashtray.
I mean,
so very cool. Like as I said, like coming to an end. I'm very sad that we come to an end, but we are going to on the racetrack.
Yes,
so
we'll be moving
special surprise.
This same car. We will move it to the track.
Yeah, maybe at the end, like, do you have any kind of other message or information or something that you want to share with us? Is there any kind of future developments, any plans, any?
Yeah. We are very much
like future. This time what you told me in the break, like this flying mode, like.
The flying mode. Sure, and the submergible mode as well. So we are, of course, we have several things in the work that are not quite public yet. But I'm gonna say that we are gonna build a very nice car with a lot of horsepower that's gonna look very nice. And sometimes in the future.
So like a successor of the Nevera.
Successor of Nevera, but not only Nevera, but successor of the Bugatti Chiron as well. So that's in the works as well. The design and the whole thing hasn't been made public yet, but it will be soon. And we are very excited about this, especially because we're taking over. We've taken over a 100-year-old brand. Essentially like the crown jewel of the automotive industry. And we've been entrusted, and that's a big responsibility, right, to make this work. But I have no doubt that we'll impress everyone.
I mean, I just want to tell you like congratulations for all the story for the whole team. It's really an impressive story
team.
from Europe. Fastest supercars, a lot of technology, all from the ground, innovation at its best. So that's really impressive, and looking forward to the next one. And thank you for being my guest. And now I can't wait to go on the track.
Yeah.
So thank you.
Thanks. Looks like here.
Just to warm up.
Yeah, to warm up.
Really
to warm up the tires and for you to warm up. Oh, I could have went there. Doesn't matter. So yeah, you're currently in one of a few unique cars in the world.
What does it cost actually to buy one?
I think the starting price is roughly 2 million euros. Now everyone always jokes, so wait, starting price, that means you get to pay more, you know, for rear view camera and stuff like this. Not really for the camera and stuff like that, but you can customize it quite a lot.
Yeah, it's a nicer leather or something.
Yeah, if you can, I don't know, if you want a lot of exposed carbon or something like this. Yeah. So let's do a first little casual run. I'll give you a bit of taste of speed, but nothing too crazy.
It's pretty comfortable.
Yeah?
It's very low.
Like it's set up for a very I mean it's a sports car.
Yeah,
it's a sports car, right? So essentially, it's a very comfortable car, even if you want to take it for a very light spin like this. But if you want to go crazy, all you have to do is just tweak these knobs. Put it in, for example, track mode or sport mode or drift if you want to go sideways a bit more. And this time when you press the pedal, the response is way more aggressive. The software
very
adapts
direct.
to this. Yeah, it's very direct. It's, all the pedals bite a bit more. It becomes just a tiny bit stiffer. I mean, after all, even in its most light configuration, this is still a very aggressive sports vehicle, right? But it gets even crazier.
It does even have a trunk.
Yeah, it does have a trunk. I don't know if you heard the guys talking about it, but you can fit, I think, 20 pizzas.
20 pizzas. So that was the team size back then.
Yeah. That was one of the requirements. So this is probably the lightest this car has ever been driven, especially if you look at the tire marks around it.
Yeah, it's really good.
Take us back, and this time you'll get to experience it in a slightly different scenario.
Yeah, looking forward to that one.
Yeah, our
so
lovely driver.
Thanks for the warm up.
No problem.
It's very nice to sit in here. Like
it's
good
very
sleep
comfortable.
actually. So David, thank you.
Thank you.
So you are now giving me in the hands of Angel, the test engineer.
Exactly.
For the full experience.
Yes.
Thanks for the interview again.
Thank you for having me.
Hosting us the whole day here in Zagreb.
Yeah.
And looking forward to the next time.
Likewise.